Greetings, students. This is Mr. Torgerson. Today we're going to discuss our 1.4a quadratic equations. Alright, so first item here, where the graph of a function intersects the x-axis, the point x, 0 is called the x-intercept. Sorry, this got printed off a little bit odd here. X-intercept. Now, some quadratic equations have two x-intercepts. For example, this one intersects the x-axis at -1 and +3. So this would be -1, 0, +3, 0. Some intercept the x-axis only once, which is going to come later on in the notes. And some don't have any x-intercepts. Alright, so these are called zeros. So these x-intercepts are also called zeros as well. And to find the zeros of a quadratic equations, again, this kind of got printed off weird. I don't know what happened here. So this says this is supposed to say y is equal to a times x squared plus b times x plus c. So a times x squared plus bx plus c. Solve the related quadratic equation by replacing y with 0. So you would say 0 is equal to ax squared plus bx plus c, and then you would either factor or quadratic formula this, which is what we're going to be working on here. The zero product property says if two items multiply together to make 0, then one of the two items is 0. So for example, in this particular equation, if these two items, x minus 5 and x plus 3, multiply to make 0, one of these expressions is equal to 0. So what this means is either, and you don't have to put the word either, but that's what it says here, either. So either a is 0 or b is 0. So either x minus 5 equals 0, or x plus 3 equals 0. So that's what this property says, the zero product property. And this could give us what are called the x-intercepts of the quadratic equation, which we'll get to in a second here on the next example. So this is what we're talking about here. One of these two expressions, x minus 5 or x plus 3, has to be equal to 0 because they multiply to make 0. So looking at our example 1, so our steps. Get 0 on one side of the equation using the addition property. This already has step 1 done. So this right here is step 1. Get 0 on one of the sides. Step 2, factor the expressions on the other side of the equations. Now, not all expressions are factorable, but our goal today is to work with factorable expressions. So we're going to factor the left side, the other side. So here I have the 0 on the right side. I'm going to factor the left side. So I'm going to factor x minus 7, x squared minus 7x plus 12 equals 0. So there's many different methods to factor. There's not one particularly always correct method of factoring. So you can do lots of different types of ways to factor. So every method pretty much starts off by identifying the coefficients a, b, and c. The squared coefficient, the linear coefficient, and the constant. So pretty much all of the different factorings start off by saying a is equal to 1 in this case. So this is a right here. That's a. Then b is going to equal to the coefficient of the linear term, or the coefficient of x. That's b. And then c is going to equal the coefficient of the constant, the constant term. It's coefficients if it's in front of a variable. It's a constant if it doesn't have a variable. So that's a constant, C, 12. Alright, so one of the methods to factoring is this x factor method. So in this top box, we're going to put a times c, which in this case there's only a 12. In this bottom, we're going to put b, which in this case is -7. And in the left and the right, we're going to put the factors of A times C that add to make B. Now I'm going to restate that. The factors of A times C. So when you take two items to make 12, what two items can you use? So we're going to practice this with the first set of items, and we're going to state why the first set of items doesn't work. So 12 and 1 is a factor of 12. 12 times 1. But that does not add up to make -7. So these are the wrong factors of A times C. They don't add to make 7. 12 and 1, they don't make 7. Don't add to -7. So that's why I'm not using 12 and 1. So then I can go off to another set of factors. Now to get another set of factors besides 12 and 1, the most natural thing to do is to increase the smaller factor by 1 and to see if that number goes in. Does 2 go into 12? Yes, 2 and 6. 2 times 6 is 12, multiplied together. But then again, those don't make 7. So I can cross these out. So those also don't add to -7. So the 6 and 2 doesn't work as well. So then the next natural set of numbers to do is to increase the 2 by 1, the smaller factor. You always just increase it by 1 each time and see if the number goes in. Now, not all things go into 12, so you're going to have to actually see if the number goes in. And you can use a calculator here if you need to. So like 3, does 3 go into 12? Yes, it goes 4 times. So I'm looking at this 3 and the 4, and that is a positive 7. So I can make this a -7 by making them -4 and -3. So -4 and -3. So these ones add to 7. So I'm not going to cross these ones out. These ones add to -7. These are my factors that I want to use. The factors of A times C that add to B. Now when A is 1, these are actually your expressions. X minus 4 and X minus 3. When A is not 1, you're going to have to divide by A to get your proper expressions, which I'll show in a second here. So because A is 1, because A is equal to 1, A is 1, you can just use these directly. Alright, you don't have to modify at all. So we're going to have here X minus 4 and X minus 3. Now they can be in either order. The order here doesn't matter. So in other words, X minus 3 can come first, or X minus 4 can come first. And then I can set those individually equal to 0 to solve those expressions for the x-intercepts. This will give me the x-intercepts of this parabola if it was equal to y, or in this case it just solves the equation because it's equal to 0. It doesn't have a y here to start out the question, so we're just setting this equal to 0 and then we're solving it that way for our values for x, our solutions. So either x minus 4 is equal to 0 or x minus 3 is equal to 0. So either one of these is either x minus 4 equals 0 or x minus 3 equals 0. So we can add 4 to both sides here. So we could say here that x is equal to 4 or x is equal to 3 for our two solutions. You can very easily verify your solutions by substituting them back in. So if you substitute the 4 back in, and you can use a calculator here. Let me grab my calculator from my desk. Here's my calculator from my desk. Again, you're welcome to use a calculator for all of the work for topics of for college prep math. So 4 squared minus 7 times 4 plus 12. Is this equal to 0? Yes. And then 3 squared minus 7 times 3 plus 12. Is this also 0? Yes. Later on in the work, not today, but another day, it's going to become important for you to check your answers. Not today's work, but later on in the semester, it'll be important for you to check and make sure that these values actually work. All right, so there is page 27. Moving on to page 28. We have a bunch more different equations to solve for x. It does say to solve by factoring. So again, we can use A, B, and C here. Now some of these are easier to do using alternate methods. So here we notice that we don't have a C term. So when C is equal to 0, every time that C is equal to 0, notice A is 8, this is A again, B is negative 16, there's no value of C here because there's no constant, or in other words the constant is plus 0. When C is equal to 0, what you can do is factor out a common term between the first two. Factor ax squared plus bx. Just factor the first two. So the 8 and the 16 both divide by 8. Now the numbers don't have to have a common number here. If they don't have a common number, that's fine. Just pull out an x. But here they both divide by 8. So we have 8x times the quantity x minus 2. So where did this come from? 8 times 2 is 16x. And 8x times x is 8x squared. Now this doesn't have to have a common number. You don't have to have a common number between these two terms to do this. If they don't have one, I would just pull out an x. In fact, I could do that each time and leave the 8 inside and I still get the same answers. Okay, so if I left this 8 inside, this would be 8x minus 16. We'll come back to that in a minute. And we'll show you how it's the same answers. So this is equal to 0. So this is again the same thing. So either 8x is equal to 0 or x minus 2 is equal to 0. So this gives me x equals 0 or x is equal to 2. Now I know it bugs some of you that I'm just putting x is equal to here, but that's because these are already equations. We're not working with parabolas right now. So some of you are thinking, why does this not have the point 0, 0 and then 2, 0? That's going to be when we work with actual parabolas. So don't let that bug you if it is bugging. It's bugging me a little bit here. But what we're working on right now is only these items. The solutions is what they're called. We're not working on the x-intercepts because it's not a equation. It's not a parabola equation. Alright, this next one, notice that the b is not on the same side as a and c. We have to have this set equal to 0 as our first step. Get 0 on one side of the equation. That's step 1. So what I'm going to do here is take this 9x, move it over to the other side of the equation, and then identify a, b, and c. So now I can identify a, b, and c because we have it set equal to 0. So now I can say that a is equal to 1. Again, the a is right here. Sometimes it's not 1, sometimes it is. In this case it was 8 because 8x squared. In this case it's a 1 because 1x squared. So a is equal to 1, b is equal to negative 9, and c is equal to positive 18. So again, for my x factor, or you can call it box factor, there's many different ways to factor. Again, if this is not your preferred method, use your preferred method. So in this top box, I'm going to put a times c, which in this case 1 times 18 is 18. In this bottom box, I'm going to put b, which in this case is negative 9. And then I'm going to start off with my first set of factors, which is always 1. So 1 times 18. So do these add to make negative 9? Well, no, they add to make 19. So this does not add to make negative 9. So these two are incorrect because they don't. Now I'm writing this out each and every time because some of you are confused on how to do this. I don't expect you to write they don't add the negative 9 here. Okay? I don't expect you to write that out in your homework. Let me be clear here. I'm just writing it out to try to explain this to you as we're going through it. So again, the most natural thing to do here is to increase the smaller factor, which is always a 1, by 1. So and then ask yourself, does 2 go in? 2 goes into 18 9 times. 2 times 9 is 18. But this, again, does not add to negative 9. This adds to 11. So this doesn't add, they don't add to -9. So again, the next thing you would do is check 3, because 3 is 1 bigger than 2. Always increase the smaller number by 1, the smaller factor by 1, and just keep going up one at a time. So 3, does 3 go into this 18? Yes, it does. It goes in 6 times. But then I notice that this is +6 and +3, and I need -9. I can fix that by making both of these negative once again. Because again, I want a -9 when they add and a +18 when they multiply. So this is the correct one to use. These ones add to make -9. These two add to make -9. -6 plus -3 is -9. -6, let me state that again. -6 plus -3 is -9, and they multiply to make 18. So those again are my factors directly. Because A is 1, these are my factors, my direct factors. Now if A isn't 1, we're going to have to do something else, which we'll show in a bit here. So here we got x minus 6 and x minus 3 is equal to 0. So again, what that tells us, once we write that part down, is that either x minus 6 is 0 or x minus 3 is 0. Which means that x is equal to 6 or x is equal to 3. Because we add 6 to both sides and we add 3 to both sides on that second equation. So x is equal to 6 or x is equal to 3. Again, the amount of work I'm showing here is an exceptionally large amount for the majority of you. I would not expect the majority of you would show out this exact amount of work on these particular questions. I'm explaining this using the maximal amount of work here to help those that don't understand what they're doing to understand these questions. Alright, example C. Example C has no B term. So when there's no B term, you're still going to start off by moving the 45 over. I would start off this way. Not all teachers would. So let me really reiterate that. I would start off by subtracting the 45. Actually, when there's no B term, there's multiple methods to doing this. And if I move the 45 over, I might actually end up doing extra work. So I need to keep that in mind, because I'm looking at this, it only has one variable. There's only one term with a variable. Unlike the other ones, which had 2 terms with a variable. What I mean by that is here there's an x squared term and a 16x term. Here there's an x squared and a 9x term. They have 2 terms with variables. Here there's only 1 term with a variable. So this you can solve by putting the variable on one side and the numbers on the other. So this is actually not done through factoring, in my opinion. But I'm not going to use factoring here. I'm going to solve this by isolating the variable. Alright, so I would move the 20 over to the 45 through division. So x squared is equal to 45 divided by 20. Now this can be simplified into 9/4 by dividing top and bottom by 4. By 9, not by 4. By 9. By 5. 9, not 5. So then I can say that x squared is equal to 9/4. How did I get to 9/4? Again, I took 45 divided by 5 and I got 9, and 20 divided by 5 and got 4. I simplified this fraction. And then what I can do is I can square root both sides. So x is equal to either a positive or a negative. When you take a square root of both sides, you get positive and negative value, 9/4. Which you can actually take that square root of top and bottom separately and make that into 3 and 2. Positive and negative 3/2. Here would be a good time to check my work, because I got a fractional answer. This would be an excellent time to take out a calculator and say, does 3/2, 1.5, 3/2, actually work for this equation? So I'm going to look here, I'm going to say, does 20 times by, how do I put 3 halves in? Well, I can put in 1.5, or I can use a parenthesis 3 divided by 2. Does this, when it's squared, 20 times 3 halves squared, does this in fact make, yes it does, it makes 45. And then, does it make 45 if it's a negative 3 halves? Well, of course it does, because a negative squared is going to be the same as a positive squared, if it's a quantity. But I can verify it very easily, yes. So 3 halves is my answer, positive and negative 3 halves. So when you get answers like this is an excellent time on a test or a quiz to take out a calculator. You could use it the whole year, the calculator, any calculator you want on the computer. I recommend Desmos on the computer if you're working on the computer or your phone, DESMOS. You can take out a calculator and say, does this actually work? Is this actually the solution? The answer to that is yes. Alright, so the next ones, it says to actually use a calculator. So again, the Desmos calculator on your phone, you can actually use a calculator, the Desmos calculator, to actually type these in the calculator, and you can make a table of values from that. If you don't want to use a calculator here, it's going to be a bit longer because you're going to have to guess and check answers for X. But they're going to start off the same way. Set them equal to 0. So you want to set these equal to 0. So this 2 is on the wrong side, this negative 2 here. So I'm going to add the 2 over. So it's on the same side as the linear and the squared term. I'm going to get negative 2x squared plus 3x plus 2 is equal to 0. And now I'm going to either use the table on the calculator to graph this, or I'm going to do it by hand one at a time. Which by hand one at a time takes quite a bit of time. Now if you want to factor these two, you're welcome to on a test, because most of our tests are not going to be right on for this material yet. So you're welcome to write down, you're welcome to actually do this without the use of a calculator. But anyways, the Desmos calculator will graph these as well. So you don't have to use a TI-84. And yours is going to be different than mine because this is a super old calculator. I don't have my TI-84. So mine's y equals x. You'll have that y equals x somewhere. It'll be this top one here. Sorry, my calculator's super old. I forgot to go to school and pick up the other one. I don't want to go back right now. Plus 2. Oh, I want plus 2. So I type it in into the y equals. Is what I do there. Alright, and then I'm going to graph it. And you'll come up with a window. These 2 points right here are going to be where my zeros are. Right here, it looks like that's a negative 1, and that's a positive 2 or 3. So I can use a table here, using the table function of the calculator, or I can use the... So the table function on this one, forget where it is. Oh, there it is. There's my table. So anytime where the y is a 1, that is an x-intercept. Which means y is a 0, that's an x-intercept. So you see here it says 2, 0. Well, that is one of my intercepts. So I'll put that on the bottom here, the bottom row, 2, 0. And then it says 1, 3. So to read these tables off, you just say well, x and y, x and y, x and y. Then there's 0, 2 above that. And if I keep going up in the x values, I notice here that at negative 1, it's at positive 3. Sorry, negative 3. And then at negative 2, it's at negative 12. So what that means to me is that one of the zeros is at 2, but the other 0 I don't know yet. It's not an integer 0. It's not an integer value of 0. So that other 0 is not, it's between 0 and negative 1. One of them is 2, but the other one is not. So 2, 0 is one of the zeros. Now this time I'm writing it as a point because I'm looking at actual zeros. I'm not looking at solutions only. I'm looking at zeros here for this. Well, actually, wait a second here. The original was an equation. X equals 2. It was not originally a y equals. So I don't need to have the whatchamacallit, I don't need to have the y coordinate, 2, 0. To find the other zeros given one of the zeros, you know that this factors with an x plus 2. One of the factors is x plus 2. So that means you need to find the other factor. So I can use this factor to help me factor this out, and I know it doesn't factor using integer values for the second one. It's going to be, or I know the second solution is not integer. But I know one of the factors is x plus 2, and I can get the other factor here by using that factor. So when I look at this factor x plus 2, that means that this number has to be a 1. Why does it have to be a 1? Because 1 times 2, excuse me, this is x minus 2. The factors are always opposite. Again, it's been a long summer. Because this makes positive 2 as its solution. So I know that this has to be negative 1 and negative 2, because that's going to be multiplied to make a positive 2. And then here at this front, if this factor is x, this one's negative 2x. Because negative 2x times x is negative 2x squared. So now I've got my second solution right here. Negative 2x minus 1 equals 0. And if I add that up 1 over and then divide by 2, I get x equals negative 1/2. So the calculator can help us find that second value if I just find one integer solution. You can also make the calculator so its table goes by halves instead of by ones, using the table set function if you can do that on your Desmos calculator, which you can as well. Alright, this second one here, take the 4 over to the 7, changes the 7 into a 3. Add the x over to the 14x, changes the 14x into a minus 13x. Equals 0. So again, what I can do here is I can type this in. And again, you can use the Desmos calculator if you want to at home. So I'm going to have 4x squared minus 13x plus 3. I can look at its graph, and I can see if I can actually see any of these intercepts on the graph. And it looks like we have two intercepts here. This one right here looks like it's integer. This one here looks like it's going to be a fraction. So I'm going to guess this one's an integer of 3. How do I verify it's a 3? Well, I can plug the 3 into the equation and see if 3 works. Or I can go to the table, and I can see, well, does it have an x-intercept at 3? And it does. 3, 0. So I can start this table off at 3, 0. 3, 0. Then I'm going to say, well, the next one says 2, -7. Then there's a 1 and a -6. And then there's a 0 and a 3. And then there's a -1 and a 20. So right between these two values, it crosses the x-axis. How do I know that? Well, one thing I know, I saw it on the graph, between 0 and 1 across the x-axis. Another thing here is it goes from negative to positive wise. So again, this 3, 0 tells me one of the solutions is at 3, at x equals 3. What does that tell me about my factor here? Well, that tells me one of my factors, since x is equal to 3, that one of my factors is x minus 3. Or something that is the same as x minus 3 equal to 0. Which in this case, there's only one way to have that. It's got to be x minus 3 because there's only a 3 there. So that tells me one of the factors is x minus 3. Well, what does the other one have to be? Well, to make minus 3, it's going to have to be minus 1. Because -1 times -3 is positive 3. And then to make the 4x squared, that's going to have to be a 4x. So then this will give me 4x minus 1 equals 0. Well, that's going to be x equals 1/4. Add 1, divide by 4. And again, I can verify if 1/4 is the solution by plugging it into the original equation and seeing if it makes 0. So if I want to verify specifically, does that actually work, this 1/4? I could say 4 times the quantity 1/4 squared, or use 0.25 squared, minus 14 times the quantity 1/4 plus 7. Is this a 0 or not? That's what I'm asking. Oh, Sorry, I should have used this one, not this one here, because this one here equals 4 minus x. I kind of did that on purpose. You should use this one that equals 0, not the original one here that equals 4 minus x. So I'll go back up by pushing the up arrow if I have the newer calculator. If I have this old one, I did something else. But so it's going to be not 14, it's going to be 13, and it's not going to be plus 7, it's going to be plus 3. It's at plus 7. And you see there it's equal to 0. I used the second one properly now. So again, when you're working these through in the notes on the homework, you can use a calculator and you can plug them in and see if they actually make 0, if you're at all confused about your answer being correct. Alright, that was page 28. Let's move on to page 29. Use the 0 feature of a calculator to find the solutions to the nearest hundredth. So there is actually a function on the calculator that will give you the zeros directly. And this is probably the easiest way to do these. And that works a similar way on decimals too. Not the same, but it works similarly on decimals. So when you plug these in, so let's say x squared plus 2x minus 24. X squared plus 2x minus 24. If I go to graph that, and I see that it crosses the x-axis, or I see where it crosses the x-axis here and here, I can go and I can choose what's called a 0. I believe it's under, and then the new calculators have zeros. This one has what's called a root. So I know it's going to be left bound. It's going to the left around about 3 at x equals 3. And it's going to be right bound at, that looks like that's 4. So I'm going to say x equals 5. And I'm going to guess that it's x equals 4. And that was correct. The root here, or the 0, yours is going to say 0 because this is an old operating system. The root is 4, 0. So one of my solutions here is x equals 4. And then if I look here, and I do the same thing, and again yours is going to say 0 here. Mine says root because it's super old, the calculator. Left bound, I'm going to say that's about 1, 2, 3, 4, 5, 6, 7. Negative 7. It's going to the left at negative 7. And then right bound at negative 5. I'm guessing it's at negative 6, which it probably is at negative 6, 0. X equals negative 6. So that is how you can use a calculator to do this. Now again, you don't need the TI version of calculator. It's an 86 from like 1995 is when these came out, 94. You can use any version of a calculator that has a 0 function. It's going to be called 0 on the new versions. The old, super old ones are called root. So yeah. So let's try another one here. And again, on decimals, it's called root. And it'll say left bound, right bound. Left bound, you want to pick to the left where it crosses the axes, the x-axis. Right bound, you want to pick to the right. So let's go back and do the next one here. So 1/2, 1 divided by 2, or you could do 0.5, x squared minus x minus 6. Why am I using minus 6? Because I want everything, I want it set equal to 0. It's not equal to 0 here. So I'm going to say 1/2 x squared minus x minus 6, not plus 6, equals 0. Alright, and then I can do second graph. And I can look here and I can say, where does it cross the x-axis? So right here, I'm looking at the right side crossing, the one to the right of y equals 0. So I'm going to try to find that one first. So I'm going to do, mine's called math and root, yours is just going to be called 0. So 1, 2, 3, 4. So I'm going to say x equals 4 is my left bound. And then my right bound is going to be x equals, well, that's like about 5 right there. So it's going to say x equals 6. I'm going to guess it's at x equals 5. Why 5? Because that's very close to where it crosses the x-axis. It's very close to 5. It's not exactly 5, but close to 5. So here is my solution. Now this number right here, this negative 8e to the negative 13, this is called a calculator rounding error. That's a 0. Why is it 0? Because look, it's where it's crossing the y-axis. So this is very close to 0. It essentially is 0. It's a 8 with 12 zeros in front of it. So 12 zeros after, and then an 8. So decimal 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 0, 8. And again, you can see here that y is essentially 0. So x is equal to, I'm just going to round to the hundredths. So x is about 4.61 for that solution. Now again, I can go and I can verify. Oh, sorry, I'm not working here. I'm working here. X is about 4.61. So back, and we're going to go back. We're going to calculate the next 0. So this one I'm going to guess -3 or -4. I could do -3 or -4. And then I'm going to guess -2. And my guess is going to be either one of those two numbers. So I'm going to say, well, it's very close to -3. Try going from -3 downwards. So I'm telling the calculator there. About 2.61 negative. These are my two solutions. Now again, I can verify those two solutions by putting them back in for x and seeing if they actually do work. It's not going to be exactly 0 when you plug those in though, because we did have some rounding. So when I do 1/2 times by, or I should say, let's do a parenthesis, 4.61 quantity squared minus 4.61 minus 6, this might not be exactly 0. So minus 4.6161 minus 6. This might not be exactly 0. It's going to be very close to 0 because there's some rounding error here. So it should be very close to 0. 0 and 1 and 200ths, 0.01262 or 5. So it's very close to 0. Again, that's because of rounding error. And again, if I did the other one with -2.6, -2 and 61 hundredths, and then I did, that's going to be positive 2.61 now, 2 and 61 hundredths. This is going to be very close to 0 as well. And it's going to have the same amount of error. Again, this letter C, because there's no B term here, I wouldn't use a calculator at all on this question. I would add 5 to both sides. That would give me 2x squared equals 5. I would divide it in half. X squared is equal to 5 halves. And then I would square root that number. X is equal to the positive and the negative square root of 5 halves. Here I don't have to round at all. I can leave an exact answer. So if there's no B term, there's no need to do it on the calculator. And I don't care if you do it on the calculator or if you do it by hand. You can pick either method. Alright, so our next items, using a quadratic equation. So here we're going to have an example here of word problems. We're going to have that for our next 3 questions. So the height and feet of a ball thrown by a child is this quadratic equation, where x is the horizontal distance in feet where the ball, when the ball is thrown. How high is the ball when it leaves the child's hand? So when it leaves the ball, when it leaves the child's hand, that's at x equals 0. That's at x equals 0. Why is that at x equals 0? When it leaves the child's hand. If you look here, it says where x is the horizontal distance in feet when the ball is thrown. So that means that when x is 0, the ball is 0 feet away from the child. So as x increases, f of x equals 0. That's what I meant to say. So f of x equals 0. So as x increases, that's going to be the length, that's going to be how far away the ball is from the child. You get what I'm saying here? So as x increases, that's how far it is, the ball from the child. But at 0, that's going to be where the ball is thrown. Again, this question is kind of weirdly worded. So when I do this on a test, I'm not going to word a question like this, because this to me is just weird wording. So when I word this on a test, I'm going to say, what's the intercept? The y-intercept? I'm going to say what are the x-intercepts, because that's the question it's asking. That's what it's asking you to do. So I kind of have these mixed up. I had originally at the start x equals 0. That was correct on this one. It's supposed to be x equals 0. So we put in 0 for x here. Negative 1/2 times 0 squared plus 2 times 0 plus 3. 3 feet. This was asking for the y-intercept when x is 0. This one's asking for the x-intercept on the bottom one here. This one's asking for the vertex. So this one on the bottom is asking for the x-intercepts. So I can use a calculator to find these. 0 equals negative 1/2 x squared plus 2 times x plus 3. Or I can do them by hand as well. So if I want to use a calculator again, I'll find the graph, y equals. So I'm going to do negative 1/2 x squared plus 2 times x plus 3. And I can graph that, and I can figure out the x-intercepts. Now I only need the positive intercept. I don't need the negative one here on the left, because we want to figure out how far the ball goes. So if I look here on the far right, that's the one I need on the far right. So I'm going to calculate only that one. So I'm going to say it's between 4 and 6. 4 and 6, and I'm going to guess it's at 5. And it essentially is 5. 5 and 1600ths. Okay, and I can verify that that's actually 5, again with the calculator. Since it's a word problem, it'd probably be good to verify it. So if I did 1/2 times 5 and 1600ths squared plus 2 times 5 and 1600ths plus 3, and it should be a negative 1/2. So I'm going to go all the way back to the start, put in a negative sign, like so. I'd see if that's actually equal to 0, and essentially is 0. It's not exactly 0, but it's close enough. The last item here, the height of the ball, this is actually called the vertex, which we had not talked about today at all in the notes. So we're going to actually come back to this another day, how to exactly find it. But if you want to estimate it for today, it's this top value right here, the top of the curve when you graph it. And I'm not going to go through how to find it on the calculator today, because we do that another day. We're going to do that another day. But that is approximately that, and you can trace this to get a good estimate if you want. It's approximately at 5. All right, so it's really, really close to 5. In fact, it might actually be 5. All right. And I don't have to put y equal 5. Let's put 5 feet. And this would be y equals 5, the maximum height of the ball. And it's also called the vertex from last year, which we're going to get into in another day, how to find it on a calculator and how to find it by hand. I don't want to get into that today. That comes up later on in the notes. All right, last questions on the last page here. Sorry again, I'm going for super long. On this next one here, we're looking again for the vertex of the parabola. So we're working for the maximum height. So I'll graph this one as well. And I'll say, negative 5x squared plus 7x. I'll graph it. And I'm looking for the top of this curve. So right there is where I'm looking at, that top part right there. And I can trace it and get a really good estimate of what it is. Again, another day we're going to come back to this. It's about 2.5. 2.4, 2.5. 2.5, we'll guess. About 2.5. We're going to come back another day and talk about how to find the vertexes using the keys on the calculator. We're not supposed to be talking about that today, how to find that on the calculator. Anyway, so for now, just guess where it crosses. About 2.5 up top there. All right, and then part B, assume that the player hits the ball on its way down when it's 6 meters above the point of the toss. For how many seconds is the ball in the air between the toss and the serve? I'm going to skip this question because I'm not going to do this one on my test. So if you wanted to, if your other teacher's going to do that one on test, they can talk to you about it later. Anyway, that is it for today. For your homework, you're going to be doing this page, 116, and then page 117 as well. Those word problems, I know in my class I'm going to have to talk about them, all of them pretty much individually, those last three. So there's the other page of the homework, 117 for this video. I know I'm going to have to talk about all three of these in my class individually. So if you need to ask in your class about these as well, since these are much more difficult. Anyways, that's it for today. Good luck.